My name is Jim, and I am an educator performer at the Denver Museum of Nature and Science. And I'm here to perform an experiment for you as part of our outreach program called the DMNS Science Party. Now, this particular experiment will explore several parts of the rock cycle. To do this, you're going to need a bunch of materials which you can gather at home and join in with me as part of, and do this yourself. All right? First thing that you will need is 3 or 4 regular old crayons. Okay? Try and get some dark, some light, just so you have some good contrast. You will need a kitchen knife, just either a sharp one or a dull one, whatever you're most comfortable with. Either will work just fine. You will need some aluminum foil. 3 or 4 sheets ought to do just fine, about this size. Okay. You will need a cutting board to do all the work on. You don't want to be cutting into your countertops or anything like that. You will need something to put the pieces of your experiment into at one point. Either a pot pie or tart tin that you can buy at the store, or you can use aluminum foil to make your own little container, a little tin like this. Basically, I just took a square of aluminum foil, folded it into fourths, and then molded it into one of these cupcake tins so that it's just like that. Okay? These little ones actually work a little better because they're smaller. You don't use as many crayons. Now, you can use just a couple of books and stand on them, or really press on them at some point in here to create some pressure. Or if you happen to have at home some clamps, those will work as well. Then you're going to need your stove to provide some heat, and your refrigerator to cool things off once we're done. And there you have it. Now, as I said, you can join in with me with this experiment. You can simply start and stop the video as you see fit to just stay in sync with how I'm progressing. All right, is everybody ready? Let's get started. Okay, I've brought you in close so that you can see what I'm doing here as I progress through the various stages. Now, first of all, let me introduce what the rock cycle is. To begin with, it's a concept that we have in science about how the Earth processes have created the various kinds of rocks that we have on the Earth. We start off with igneous rock that was formed by melting and cooling. Usually volcanoes shoot up magma, or magma cools underground. But then those rocks are exposed to weathering and erosion, which then gets compacted together to make sedimentary rock. And then that rock can be exposed to heating and pressure, like in mountain building, and make metamorphic rocks. Now, as you can see from the various arrows here, this is not just a nice simple circle. Any one of these types of rocks can be formed into another type simply by what processes it's exposed to. And we'll talk about that as we go along. All right, back to the crayons. I'm just going to, you can take this peel here, or this label, just use the knife, just press along there with the knife, cut off the label, and it should, most of them anyway, peel off very nicely, very easily like that. I've already done these. But then what you're going to do, since these are now representing igneous rocks, because the way that the crayons are formed is that they take wax, put color in it, and then melt it. And that's the way igneous rocks are formed, deep down underground in the mantle of the Earth. The rock is so hot that it actually melts. But then as it rises up through the crust, or it erupts into the surface, it actually cools, what we call crystallizes. So that's what they've done with the crayons, is they've taken that hot liquid wax, poured it into a mold, and let it cool. Okay, so this represents igneous rocks. Now, once on the surface, igneous rocks are exposed to weathering and erosion, processes like rivers and wind, blowing sand, running water, all that sort of stuff. And that breaks down the rocks into smaller pieces. So that's what we are going to do here, is we're just going to take these chunks here, or these pieces of rock, crayons actually, and I kind of shoot a little bit, so you may want to protect your area somewhat. Now, I'm going to, we're just going to do that to all of these. We're going to cut them down really small so that we can see what's happening. Okay, so you can see here that I have finished cutting up all 4 of my crayons, and as you can see, I purposely chose 2 light colors, 2 dark colors, just to get some good contrast in my final product here. I put the penny here just so you can see kind of about the size of the little pieces that you need to cut it up into. The smaller the pieces, the better, just for what we have to do when we heat them up and make the melting process a little bit quicker and easier. Alright, so what we've just done here though is we've demonstrated how igneous rocks, how igneous rocks that started as magma, they cooled to become igneous rocks, how through weathering and erosion become what we call sediment. Tiny little particles of rock that get washed around or blown through the air. They get washed down rivers. They collect in oceans or in big lakes, and they settle to the bottom and they start to pile up. That is called deposition. And that's what we're going to demonstrate next. Okay, to demonstrate deposition, this is where the sediment, the little tiny particles of rock that have been weathered away, this is where they get eroded or carried away to like a lake or piled up somehow. That usually happens in several different types of sediment, represented by each of these different colors. They come flowing into the ocean from a river, and then they start settling down to the bottom. Over time, more and more of these particles start to pile up. They pile up one on top of the other. Sometimes one section of the river is busier than another, or one river is busier than another, or it starts eroding through a different type of material, a different type of rock, and so brings different minerals down to the ocean. And as they fall, they just start piling up one on top of the other. Just like this. Well, not just like this, but we're trying to make it as representative as possible. Okay, you can see that I'm building up different layers here. And you can do the same. Remember, as we're going through this, if you need to speed up or slow down, you can jump through the video as needed. Okay, now this is all fine and dandy as it just, as it represents sediment settling, being deposited at the bottom of a lake or the ocean, or deposited somewhere. The Great Sand Dunes is a good location to see deposition if you want. All that sand blew in from hundreds and hundreds of miles away and got dropped right there at the base of the mountains where we see the sand dunes today. If you've ever had a chance to go there, go ahead. All right, but now they're still not sedimentary rock. We need to add pressure for that. Now, over time, and I'm going to use this aluminum foil here, I'm going to close it over so that I can compress this without making a huge mess. In nature, or out in the world, this happens over millions and millions of years. The rock layers pile up one on top of the other, and gravity starts pulling them down, and eventually you get so many layers of rock that it just is incredible the amount of weight and pressure that it creates. Well, we don't have millions of years and not a great deal of weight, but you can take a book, a couple of books, and press down, or you can stand on them, or what I'm going to do is sandwich them between a couple of books like that. And I'm going to use a couple of clamps to create the pressure. Okay. Now, if you don't have clamps at home, like I said, that's fine. You can just go ahead and use, you can stand on the books, you can press on them, you can have somebody, you bring one of your parents in and have them stand on it, and you can sit on their shoulders or something to just create some pressure. Now, hopefully these crayons are going to be sticky enough that they'll actually start sticking together, and that pressure will hold them together. Okay, now I'm just going to, just a little bit here, maybe about 30 seconds or so should be plenty. But then, because in nature, there are materials that do act as glue to hold the particles together as well. So I'm going to take that apart there, put that back, and let's see what we've got here when we open it up. Yeah, you can see the layers have been squashed, and you can see we actually have sections that have kind of stuck together. Now, I didn't have a great deal of pressure here, but you kind of get the idea there. All right? That is sedimentary rock. Okay, we've made our sedimentary rock with just pressure piling up layers of sediment. And here is a real sedimentary rock. Just found this in my backyard. You can see the various layers inside here that have been piled up over time. Okay? Now, on to the next type of rock. We're going to take our packet here, and we're going to take this sedimentary rock and pretend like we have buried it down deep in the earth for millions of years. Let all that weight of the rocks be pressing on it, but then we're going to start building some mountains. Now, mountain building creates a ton of pressure and heat. All that rock pressing together from when continents collide raise up the mountains, and there's a lot of heat involved in that. Not enough to quite melt the rock, but there is enough to deform them and change it. That's why we call it metamorphic rock. That's the next type we're going to make. Okay, here we have a skillet sitting on the stove that's been heating up for a little bit. I put the skillet on there just in case it starts to leak a little bit, and I don't want my stove top having any problems. This is an old pan, so I can clean that up or get rid of it as I need. I've got my packet of the sedimentary rock that we formed. I've got some tongs and an oven mitt here, just in case. It'll probably be a little warm to touch, so you probably want to have something to grab it with. And meanwhile, I have my clamps and the books all set and ready to go, because this is going to have to work very quickly. You're not going to want to do this for more than like 10 seconds per side with this, because you don't want to melt anything. You just want to soften it up really good, okay? So here we go. There's 1002, 1003, and so on. We're just going to let it sit for just about 10 seconds here, just enough to heat it, and then we're going to flip it over real quick and let it sit for another, maybe 7, 8 seconds, since it's already kind of warmed up. And there we go. We're going to do this, and then very quickly we're going to get it in the book, and we're going to clamp them. Again, you don't have to have the clamps. You can use just standing on them or some weight. What happened? There we go. But you want to do this part as fast as you possibly can. I'm a little slow on it here. Hopefully this will still work. Alright, there we go. We're going to clamp it down real quick. Oh, for about maybe 30 seconds or so. Yeah. Just enough to really kind of press everything together. Again, stand on it. Puts a bunch of weights on it. Something just so you get some pressure here. You want to really stick those together and deform the particles. And that should do it. Okay. Let's see what we've got here. Oh, let me turn off the stove real quick. Don't forget to turn off the stove. Alright, we undo it here. And, yeah. Whoops, look what we've got here. You can see how the particles have deformed. You can still see the different particles inside there, but they're not completely changed, but they're a little different. Okay? Now, this is an actual metamorphic rock. It's called gneiss. You can see the crystals still inside, and some areas where they've been so deformed that they actually start banding a little bit. Now, in the type of rock that we call gneiss, it's actually spelled G-N-E-I-S-S, but pronounced gneiss. It's a German word. Okay? Alright, so here we have metamorphic rock formed by heat and pressure. Okay, so now we're going to take our metamorphic rock that we just formed, and we're going to turn it into the last type, actually the original type that we started with. That would be igneous rock. Remember, we took the igneous rock, we created sediment, little tiny particles, which we pressed together. We compacted them together to make a sedimentary rock. Then we put that sedimentary rock under heat and pressure to make metamorphic rock. Now we're going to melt that metamorphic rock into magma and then let it cool, and we should wind up with an igneous rock again. Alright, for this we're going to need one of those little cups that we made at the beginning. You can use a tart tin or a pot pie tin. And what you're going to do then is just take your metamorphic rock and break it up into pieces. Place it into the bottom of your little tin here. Now we're going to take this over to the stove and just set it in our skillet there and let it, if it starts to dance around, you can just kind of pop it down. And we're just going to let that completely melt. Now you're going to want to catch it just as the last few little solid particles start to turn liquid. You don't want it to completely, thoroughly, absolutely, totally melt. You want still a few last little particles in there. Okay, you can see we're continuing to melt here. It's getting close, but we're still not quite ready yet. Okay, that's about what it looks like when you're ready. Take your tongs, bring it out, turn off the oven, and you can see that it's going to just sit here and cool, but I'm going to speed the process up for a little bit and put it in the refrigerator. Okay, our igneous rock has been cooling in the refrigerator for about 10 minutes, maybe 15, give or take a little bit. And all we need to do then, once we take it out of there, is kind of peel it out of the container there, and there we have it. One simulated igneous rock made from crayons. Right? You can still see the larger crystals in there. Alright, so there we have it. Now this right here is the real thing. This is a piece of granite, an actual igneous rock, which cooled deep down underground, which allowed it more time to cool and allowed the crystals more time to grow nice and big. So you can still see all these little crystals inside here. And so there we have it, our own simulation of the rock cycle. We started off with our simulation using igneous rocks in the form of crayons. We chopped them up and made sediment, which we then compressed and compacted and cemented into a sedimentary type rock. Then we added heat and pressure, making metamorphic rocks. And finally, we melted and cooled or crystallized our simulation into an igneous rock like this. Alright, so thank you for joining me on my little adventure through the rock cycle. Hope to see you someday at the museum. Have fun.